Okay, so today we want to talk about a figure who presents with us a really interesting situation, right? She believes that this is the right time to redesign our future because obviously we are faced with a lot of like environmental problems and problems with our built environment, and she believes this is the right time to do so because we have technologies available to us, right? And she's Neri Oxman. She's a professor at the Massachusetts Institute of Technology, MIT Media Lab. Um, and it is a lab that kind of pioneers like cutting edge technology, right? What we would consider innovative, right? They did the first flat screen monitor with a touch interface. So at the time, that was a very crazy technology, but now obviously it's part of our everyday lives. Um, Oxman is an ex-doctor and also trained as an architect. So she has a background in design in the built environment. And not only that, but she also has a background in the natural sciences as a doctor, biology. Um, and her group that she leads in the MIT Media Lab is one that is multidisciplinary, right? So she works with not only different designers, architects, but also biologists and structural engineers and so and people like that. And I'll touch on it a bit more in a second, but she calls herself a materials designer, basically, where she designs different materials, and this is her way of uh, designing the future for what's around us. And her goal is to basically augment the relationship between the built, natural, and biological environments by employing design principles inspired and engineered by nature. So, meaning that the materials, she's not only inspired by nature, so the form is not only derived from nature, but the materials she literally uses are all natural, right? And she wants to change our relationship with nature by saying like building the stuff around us with all organic materials. And these areas, these products that she wants to redesign are include architecture, product design, and fashion. So wearables, things we use in our hands, and the places, the spaces we live in. And ultimately, she coins this term called material ecology because she's essentially creating new materials from organic matter. And one of her biggest arguments is that we should put aside the our ways of traditional manufacturing, right? So she's saying that the ways we've been making things since the Industrial Revolution is old, right? For example, like even something futuristic like the Amazon spheres, the picture on the left here, it's made out of hundreds of thousands of different parts, right? Different glass panels, steel, and it's not only very. She thinks it's not only unsustainable, but like there's a better way we can do this by employing nature, right? Augmenting our relationship with nature. And a picture on the right is a project she did where she basically, it's a very similar structure, but it is actually made out of silkworms. And, the material is not only natural, but she uses technologies, computational technologies to guide these silkworms to make this incredible structure.
Okay, so we saw from Neri Oxman's silk structure that it's not exactly the most applicable creation. Nobody would really want to live in it. It's not exactly good at handling heat or cold, or it's not good at handling the weather, but still it's very innovative and creative. And of course, she has a lot of opposition against her because many people don't see a direct application to the real world of what she's actually making. So it seems kind of useless to some people. And so that led us to the question, does the idea to pursue an idea justify its investigation? So this is how ideas are pursued. So I'll start with design thinking. So design thinking is more focused on the arts. It's the human-driven process of synthesis. And what that means is it appeals to the human emotion and human nature rather than logic and reasoning. It uses things that might not be able to be measured quantitatively, and so it uses human-driven process. And so because of that, it has a lot of the ability to be less substantiated, so it can be more imaginative because it doesn't have to be as reasonable. And because of that, it can also be futuristic and it can look far into the future. And it can be also very innovative. And then for the scientific method, well, when you hear the scientific method, you automatically think procedure, hypothesis. It's very rigid, and it has a focus on analyzing what has already been done in the past. Because of that, it's very historical, scientific, and it's reasonable. And it's very common in rigid disciplines like math, science, and even history.
So this is one of Oxman's most successful projects, Agua Hoja. And, this is one of her first ventures into an architectural scale, right? So Vincent talked a bit about how, most people believe that she isn't doing these projects. Like she may be doing like investigations, she may be creating silk domes, but like they're not necessarily like on a scale that is useful, right? So this is one of her first ventures on a bigger scale, right? You can see that on the picture on the top right, there is a person standing in there. So it's obviously something that, has a bit more like utility in terms of an experience than the silkworm dome thing she created. And, Agua Hoja is really an exemplification of what she wants to do in terms of the new age of manufacturing, right? So it uses a lot of, it uses a material called chitin, which is commonly found in shrimp shells and apples and leaves. So it's something that we can apply on a much larger scale, she argues. And not only that, right? So this material engineered through computers, right? Grown through computers, right? Should actually be able to do a better job than maybe let's say glass, right? Because it's able to vary its properties across the panel and create this dynamic form with a single material, right? Glass can't do that. It needs multiple panes to change angles and vary its properties. And one of the applications for that, it could be that, an area with more sunlight shining on this Agua Hoja's panels, right? The material is able to respond in a dynamic manner to that sunlight and let's say thicken that area to provide more shade. And that's something that glass cannot do. So in that sense, it's very successful. So Agua Hoja kind of stands as an example between an artistic piece and a scientific piece, right? So it can be evaluated from those two standpoints.
Okay, so we obviously see from Agua Hoja that Neri Oxman's work lies between art and science. But then that asks the question, like, where does she lie in that spectrum? And how is that important at all? And why is the work that she is doing important if it does not pertain to exactly art and exactly science? So how do they relate to each other? And then also, she seems to be doing science, but she's using very imaginative concepts and ideas. She's even coining a new term, material ecology. So how can imagination further scientific knowledge is a big question we're going to be answering. So now Dylan will be doing a drawing on how design, engineering, art, and science are related to each other, and this is especially important to the situation of Neri Oxman.
So, one of the things that Neri Oxman firmly believes is that there is an intersection between multiple disciplines, right? She works with multiple teams, right? So, obviously, we talked about how Agua Hoja is kind of in between art and science, but really, when we in the pursuit of knowledge with Agua Hoja, with this investigation, right? It's not only art and science, but it's also an engineering piece, right? and it's also a design piece, right? She is also a designer. And Oxman believes that there is a knowledge flow between all these disciplines, right? We engineer, we create utility out of scientific knowledge, and then that kind of changes our, and then we design with that, right? And then that kind of changes our context, and then art is also based on our cultural context, right? So what happens in this part, right? This part of the cycle is that, and this is where Neri Oxman lies, is that it is really the part of innovation, because how do we turn art into science, right? How do we turn something that is so abstract like agua hoja into knowledge? And this is the part where we should be really evaluating for Neri Oxman.
Okay, so now our next situation is Da Vinci's flying machine. And similar to Neri Oxman, Da Vinci is also he was also an academic of between art and nature. He drew a lot of concepts, drew a lot of art like sculptures, physical anatomy, but he also did things that were scientific, like the flying machine. And so he was inspired from art and nature, using the mythological tale of Icarus, which is art, and then the biological structure of wings from bats or birds, which is nature. It's very similar to Neri Oxman, who uses nature to build, but then uses art to design. And so both of them are very similar. And what's interesting about Da Vinci's flying machine is that although it doesn't resemble the things that we have that fly today, like a plane, it's still the source of inspiration for future aeronautical progression. Although it only looks like a glider, it still had what the building blocks of what ended up becoming the planes that we have today. And because of that, imagination is kind of the Kickstarter. For Da Vinci, it was a crazy idea that became something that became like a new discipline, aeronautics. And it's important. Imagination is important for scientific development because it inspires this interest for a field or idea to bring a whole bunch of attention to you. And that's also kind of similar to Neri Oxman, where she might be doing the same thing, but we don't know because Neri Oxman is present time and Da Vinci is the far past. So we obviously know his impact. Okay, so now here's an expansion on what Dylan was drawing earlier, which is the Krebs cycle of creativity. So you can see the four sectors are art, science, engineering, and design, which is exactly what he drew before. And so I'll just explain the entire thing. So from science to engineering, if you can create something out of science and engineer it, then it becomes confirmed knowledge because the science is now applicable to real life. When engineering becomes a design, it's a form of utility. Engineering now has a utility, a niche that it can fit in the real world. And then if your design becomes an art, well, then you've kind of changed culture. You've changed the behavior of society a bit. And so then what Neri Oxman mostly focuses on is the jump from art to science, which is it's often what creates the most innovation. It creates information and inspiration for future science to come. And also you'll see it says philosophy between the art and the science. And so that's kind of saying how it's more imaginative. Science is known to be very reasonable, very scientific through the entire thing. But when you go from art to science, it's suddenly very philosophical, it's very imaginative, and it allows for a lot of potential sciences to be created out of it, but many may not have the potential to become as famous as something like Leonardo da Vinci's flying machine, which led to aeronautics and the science of how to fly something. So in conclusion, to directly answer the question, justification of investigation is dependent on the discipline that you look at. So because Neri Oxman and Da Vinci both kind of lie in art and science, which is also the realm of design thinking and scientific methods, it's stuck in the middle. So because of that, there's often a lot of debate between if it's a thing that's worth researching or not, because you could support the scientific view and see that Oxman obviously has no application and therefore it's not very it's not a valid reason of doing her work. Or you can take it from an artistic perspective, where basically anything works as an idea and it's valuable. So the discipline that you're actually focusing on matters. And so when it's multidisciplinary, it's very hard to answer. And then also there's the idea of time, where for Oxman and Da Vinci, one of the main differentiating factors is its time. Da Vinci was during the time of the Renaissance, where, well, we have 500 years now to look back and see that Da Vinci was probably impactful because he was the inspiration for his flying machine. He was the inspiration for how to aeronautics and how to create airplanes for fast travel. But for Oxman, it might not be so clear because she's in our current time period, and we have no idea whether the things like her things that she's creating, like Agua Hoja and the Silk Dome, are even something that might be appearing in the future. So, but there's still a possibility of success, which means that these things should still be justified. Because if none of these ideas like these are justified, then the progression of science and knowledge in general will become greatly slowed without any jump starts to inspire scientists. They will be forced to make small baby steps to future innovations and possibly never be able to make anything incredibly innovative at all. And then in the fields of design, art, engineering, and science, it's impossible to say that it's justified because the investigation is often in multiple fields. Even when it's complete, even if you say it's in science, it's likely part of something else, or more often than not, if it's art, it's part of something else too. And so for that reason, you cannot 100% say the justification is 100% justified or 100% not justified.
So what does this mean when we judge the innovative and the novel, right? This means that when we look at the Krebs cycle of creativity, right? Because as Vincent mentioned, right, the pursuit of knowledge is not only, so like when Oxman is creating this design, right, it's not only art, it's also science, it's also an engineering piece, it's also a design piece. So therefore, right, we can't judge a new innovation based on its value in only one discipline, right? We can't use we can't use one person's perspective to judge it, right? You can't say, "Oh, I'm an engineer, and this design doesn't have any utilitarianistic benefits, so therefore, it's a failure." But what if it has value in art? What if it has value in science? What if it has value as a design piece, right? Obviously, Da Vinci's flying machine, right? Probably had value as an art piece, but for engineers at the time, it would have been crazy. As scientific research, it would have also been crazy. But time proves that the designs he made had a lot of value for the aeronautics of today. And so when we look at Oxman, when we look at her innovation, we can't look at it from one single perspective, and instead it should be a multidisciplinary, holistic view. So ultimately, when we're looking at the new and the innovative, right, we should train ourselves to not judge, not evaluate these things based on our own our own expertise. Instead, it should be looked at through multiple lenses, multiple perspectives.